Angie got a new math teacher mid-semester, and this math teacher does not make videos for the pretest or the test, so I am now doing that. Yay! This is the pretest for Unit 8. It's Univariate Datasets, and we're just going to go ahead and go through this whole thing together because you don't get graded on this. So let's start with item number 1. It says this data set represents a survey sent out to a math class about how many hobbies the students participate in. Based on the dot plot, choose the set of statements that accurately represent the data distribution. So we're just going to start and go through each one by one, and if it isn't true, we'll cross it out, okay? So it says, the first one says there's 15 people participating in this survey. So how you find this is count the number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are indeed 15. I'm going to go ahead and write that down because I know I'm going to forget it in 5 seconds. So there's 15 people here, okay? I need to make that a lighter weight. Okay. Most students participate in 2 hobbies. That is also true. You can see that here because there are the most number of dots at 2. Okay. More students participate in 4 or more hobbies. So they're making the cutoff right here. They're saying more students participate here than here. So 1, 2, 3, 4, 5, 6. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. That one makes this statement false. There's not more here than there. Okay, let's go ahead and erase that. Let's move on to the next one. There are double the number of people who picked 3, okay, in comparison to the number of people who picked 4, 5, or 7. That is true. There's twice as many dots here as for 4, 5, or 7. So far this is correct. 15 people participated in the study. That's also correct. The highest value selected was 8. Nobody selected 8. That is eliminated. There are 8 people participating in this survey. Well, that's gone already. There's 15. So this one has to be correct. To be on the safe side, work through it, make sure it's actually right. There are 15 people participating in this survey. Yes. And most students participate in 2 hobbies. Yes. More students participate in less than 4 hobbies, so they put the cutoff in the same place, than the number of students who participate in more than 4 hobbies. And we know that because we already checked that. So this is your correct answer. Now, these are going to be shuffled. So you can't just say, okay, item number 1, the answer is 4. You either need to pull it up and do the test right now as we're going through it, or write down this big long garbage, whichever one you prefer to do. And since I have to do this, we're going to get lots of eye candy during this because I need that in my life. Okay, item number 2. Which of the following best describes the shape of the histogram? Most of the data is in the center of the graph. Maybe? The data is split between the right and left sides of the graph? No, that would be like high here and high here. That one's not right. Okay. Most of the data is on the right side of the graph? No. That would mean that the dinosaur's head was here and the tail was over here. Most of the data is on the left side of the graph. Yes, I would say this is accurate. So I would say get rid of this one because really most of the data is over here. Okay, so most of the data is on the left side of the graph. Dinosaur's head, dinosaur's tail. Okay, there's your answer. Ooh, and some more eye candy. Who is cheering us on? He cares whether or not you graduate. You should do it for Yunjin, okay? Based on the frequency table, how many students are taking 16 or more class credits? Okay, so our cutoff is going to be right here, 16 or more. So all we do is add the frequencies, so 8 and 12, which is going to give us 20. So our answer is right here. Okay? Oh, Felix, thank you for believing in us. Here's item number 4. Given the data set 15, 10, 12, 11, 5, 8, 25, 30, 9, and 6, what parts of the 5-number summary would change if a new data point of 15 was added? So the first thing we need to do is put this sucker in order because it's very obviously not. So we have 5. Go away. We have 6. Go away. We have 8. Go away. We have 9. Go away. We have 10. Go away. We have 11 and 12. Choop. Go away, go away. We have 15. Whoop, that's a beautiful 15. Boop, we have 25. And our last one, which of course I can't fit because that is my, extra super special power, is 30. Okay, we've got them in order. Now, we need to figure out the 5-number summary for this, and then we need to add a 15 and do another 5-number summary. So our first 5-number summary, minimum is 5, maximum is 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle number is going to be 5.5. 1, 2, 3, 4, 5.5. So our median is going to be 11. Now we need to find the middle between 5 and 11. So 1, 2, 3, 4, 5. Middle is that. So it's 8. And 1, 2, 3, 4. I did something wrong. 1, 2, 3, 4. 1, 2, 3, 4, 5. I did not find the median. The median. Oh, it's because I'm supposed to have 2 numbers. Watch yourself. Don't be like me. So our median is actually 10.5. 10.5. Which means that we have a dividing line right here. We don't have. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Look how much better that works. So this number is still 8, and this number is 15. There's our first 5-number summary. Now, what we're going to do is we're going to add another 15 in here. So I'm going to move my 25 down here. Okay. And we're going to erase this 25 and make it a 15 instead. Okay. Come here. Now everything is going to change because we have an odd number of, I'm going to have to fix that. We have an odd number of values in our set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now it's 5.5. 1, 2, 3, 4, 5.5. So now our new median is 11. So now we have 5. We have 30. And our median is going to be 11. So now we have 1, 2, 3, 4, 5. We still have an 8 here. 1, 2, 3, 4, 5. And we have a 15 here. So the only number that changed is right here, is our median. Same. So the only number that changed is our median. Okay? Oh, yay, look. They're having a party for us. I won't give up, young man. I'll do it for you. Item number 5. Calculate the median of the given data. So first we need to figure out how many data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 divided by 2 is going to give us 8.5. So let's go find that. I need a different color. 1, 2, 3, 4, 5, 6, 7, 8.5. Shoop, which means our median is going to be 32. Right there. All right. I'll dab for you. Oh, thanks, Ian. You dab so beautifully. Item number 6. What is the median of the following skewed data? First of all, look. They are all in order, so that's good. 1, 2, 3, 4, 5, 6, 7, 8, 9. Half is 4.5. 1, 2, 3, 4.5. There's our median right there. All right. We'll scare all the wrong answers away. Thank you. That would help me. That would help me a lot, Chongbin. Item number 7. What makes a data distribution considered symmetrical? Okay, so symmetrical means that, well, that's what we're going to talk about. When the data has no pattern. Nope. When the data forms a pattern on the right side of the dot plot. Nope. That means that it's skewed. When the data mirrors itself. Check. Bing, bing, bing. Correct answer. When the data forms a pattern on the left side of the dot plot. Keep fighting. Okay, I will. I will for you, Lino. Here's number 8, estimate the mean of the data in the data plot. So mean is the one that's mean and being a bully. It requires us to actually do math. So let's start with counting how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we have 15 data plots total. And then what we need to do is we need to add all of them together and then divide by 15. So we're going to use just 5 as this, 6 for the value for this. Okay, so let me grab my calculator. So you have to add 1 for each dot. So it's 5 plus 5 plus 6 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 plus 7 plus 8 plus 9 plus 9 plus 10 plus 10. Okay, that's all 15 values. That gives us 105, and we're going to divide that by 15, and that's going to give us the mean, which is 7. So the mean time an alarm is set for is 7 o'clock. Okay. Da-da. I'm so funny. Okay, estimate the mean and median of the data in the histogram, and then determine which of the following statements is true about the data. So let's see. To find the mean, first we need to figure out how many values we had. So there's 2 here, 3, 4, 5, 6, 7, 8. And 8 plus 8 is 16, plus 6 is going to give us 16 plus 6 is 22. So we had 22 values total. Okay. Now we need to figure out what to divide it by. I'm not sure I remember with histograms. This is why I hate unit tests. So, okay, give me a minute. Okay, looking at these answers, it doesn't expect us to have an exact number for the mean, which makes sense because we don't have individual data points, so I can't tell you what the values are for this. But we can figure out the median because we have 22, so the median is going to be left skewed because the dinosaur's head is over here. The median is going to be somewhere over here. So, and then these are outliers, these over here, because most of the data is right here. So the median is the most accurate measure because the outliers screw with the data. So the median is probably going to be in this unit right here, and the mean is going to get screwed with because of the outliers. So the mean is going to be somewhere over here. So the mean of the data set is not going to be greater than the median. That doesn't make sense. The mean of the data set is less than the median does make sense. We can't say what the mean is because we don't have individual data points. The mean of the data set is equal to the median. That only happens when the data set is symmetrical. So that's the answer. Bye-bye. Thanks. Thanks, Bing Chan. Thanks. Okay, create a histogram for the data in the table. Which of the following would be a good descriptor for the data set? Okay, so to create a histogram, let me change my color because that's going to look awful with all of this. Okay, so what we need to do is we have a number line first. So I'm going to put my little number line right here, and we're going to draw over the top of you. I'm sorry. But we have a 0 here, we have 1, we have 2, we have 3, we have 4, and we have 5. Okay, and what we're going to do is I'm going to count by 25s and make it messy because that's how I feel. That I can't do 15s. 15 is too hard for me. So at 0, we had 1, 2, 3. At 1, we had 1, 2. At 2, we had like half a 1. At 3, we had like half a 1. At 4, we had 2. And at 5, we had 3. And now I'm just going to connect these so they look like more like a histogram, like a bar chart, okay, or a graph, or whatever you want to call it. Histogram is the correct term. Okay, so this is what it's going to look like. So as you can see, looking at this, this is obviously symmetrical, and it's a U-shaped graph. Okay, so let's go and read these. Median as a measure of center or most occurrences, which would be a good descriptor for the set. Median is a good, it's not a measure of center, but it's, well, yeah, it is. But this most occurrences happens here and here, okay? So to say either or, yeah, I guess it would be right, but let's see if there's a better one, okay? Mean as a balancing point. So the mean and the median are both going to be the same for a symmetrical graph like this. And this one, we need the balancing point because it's U-shaped. So this one is already being more accurate than this one. So let's get rid of this one. Mean as a measure of center or most occurrences. Again, mean would work, but the most occurrences, I mean, this is kind of vague, so we're going to get rid of that. This one still makes more sense. Median as a measure of spread. This isn't even a thing. We've never talked about measure of spread, so this one has to be the correct answer. Bink. All right. Here's number 11. Two soccer teams tracked the number of goals they scored per game using dot plots. After 10 games, the mean number of goals for each team was 3 goals. Why is the average deviation from the mean different for the two soccer teams? So first of all, you can see that 3 goals was the same for both teams. So that makes sense. And what we're looking at is average deviation. Okay, that means that this is going to be like the mean and median for both of these. They're both symmetrical, okay? So we're talking about how far away these other numbers of goals were for each. You can obviously see just looking at this that soccer team A had a greater spread than this one. This one is much more condensed. This one is much more spread out, okay? You can just see that from looking at it. So why is the average deviation, or how far the spread goes, different for the two different soccer teams? Okay? Why is this one more spread out than this one? The data for soccer team B is taller. That is true, which means that the average deviation for soccer team B is smaller. Okay, it doesn't matter how tall this is. That has nothing to do with spread. Spread is how wide it goes. So this cannot be the answer, okay? The data for soccer team B is less spread out. That is true, which means that the average deviation for soccer team B is smaller. That would also be a true statement. Let's keep reading and see if there's one that's more accurate. The data for soccer team A is less spread out. No, it's more spread out. That's gone. The data for soccer team B is less spread out. Yes, which means that the average deviation for soccer team B is greater. No, that makes no sense. Okay, remember, average deviation is how far it is from here. So we would do like the difference between 1 and 3, this would have an average deviation of 2. This would have an average deviation of 1, 1, and 2. Okay, these are all just one step away from our mean and median. Okay, so that's what all of that is. Okay, budding. I know it's okay, baby Brad. It's okay. I know. Okay, item 12. Which of the following correctly calculates the average distribution from the mean for the following data set? 10, 13, 17, 17, 19, 20. Yeah, it's already in order, which is great. And they want us to find the average deviation, and they're calling it average distribution here. It's probably a typo. This thing was a hot mess, this test. So we're looking for average deviation. Okay, so if we have this graph, looking at this, it's going to be left skewed because you're going to have a tail over here. It just gets bigger and bigger and bigger and bigger. Okay, so let's see here. To find our mean, it's not symmetrical, so we'd have to actually solve this. So we need to add all the numbers together to find our mean. We have 10 plus 13 plus 17 plus 17 plus 19 plus 20 divided by the number of values 1, 2, 3, 4, 5, 6. 96 divided by 6 gives us 16. Okay, so our mean is equal to 16. And guess what? Okay, now we're looking for the average deviation from the mean. So don't just circle that. Okay, what we need to do now is figure out the average deviation from the mean. We have the mean, so now we need our little table. We have 10, 13, 17, 17, 19, 20, and we need to figure out how far each of these values is from the mean. Okay, I'm getting much better at writing with my mouse than I was before. So the difference between 10 minus 16 will give us a negative 6. Is this? Nope, this is the simpler way. We don't need to deal with negatives yet. It's not asking us to be difficult. So difference between 10 and 16 is 6. Between 13 and 16 is 3. 17 and 16 is 1. 19 and 16 is 3. 20 and 16 is 4. Okay, and now we need to find the mean again for all of these to figure out the average deviation. So we're going to get our calculator again, and we're going to go 6 plus 3. Angie's doing the do it dance as she sees this. That's why I picked that. Yes. Okay, so these added together give us 18, and then we have 18 divided by 6 gives us 3. So our standard deviation is 3. The average deviation is 3. Standard deviation is when things get nasty. Okay, so there's our answer for that one. Pudding. Okay. Item 13, using only the images, which of the following, she's pounding on herself. I'm going to have to pause this. I forgot to post a video, so she's tattling to me about me. Using only the images, which of the following correctly determines which graph has a larger standard deviation and explains why it is the case. So which one has a larger standard deviation? Standard deviation is the more complicated one. Okay, so first we need to figure out the standard deviations for both of these. Yeehaw! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This one has 15. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This one also has 15. We need to find the mean first for each of these. So let's start with the top one. We need to add all our values together. 1 plus 1 plus 1 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 4 plus 4 plus 4 plus 6 plus 6 plus 6 gives us 52. Divided by 15 gives us 3.466666. Okay, we're going to go 3.47 because it doesn't tell us how far to round it because it loves me. Okay, let's do the next one. That was what the big sigh was about. We have all the zeros, so we have 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 4 plus 5 plus 6 plus 6 plus 6 plus 7 gives us 48. Divided by 15 gives us 3.2. Okay, there's our means. Now we need to figure out the majigger, the deviation from the mean. This is going to be fun. Okay. I need space, man. I guess we'll just write over the top of it. You know what I can do? I can delete this because we don't need this anymore. Go away. Okay. Let's see. So we have 1, 1, 1, 2. Oh my gosh, these are going to be big, nasty numbers because they're decimals. Okay. The first graph has a larger standard deviation because the value 4 has a higher frequency in the first graph than the value 2 does in the second graph. That has nothing to do with standard deviation. That can go. That makes no sense. The second graph has a larger standard deviation because the data is not as spread out as the first graph. This is actually more spread out than the first graph because this one goes from 0 to 7 and this one goes from 1 to 6. So that makes no sense. Go away. The data from the first graph has a larger standard deviation because the data is not as spread out as the data from the second graph. This is less spread out, but they're saying that means it has a larger standard deviation, and that doesn't make sense to me. The second graph has a larger standard deviation because the data is more spread out. I believe the answer is this last one. And your job, my dears, is to tell me if I get any of these wrong. That's a very important step for you. But I didn't put anything on there except for a red dot, apparently. Oh, no, I did. I remember this one now. Okay. That's my fourth try. I'm going to get this right. Here is our formula. This is the more complicated one. So we're going to start with, we need to find the mean, which is x bar, okay? So it's 40. There's one occurrence of 40. So 40 plus 2 occurrences of 50, 50 plus 50, 1 occurrence of 60. That gives us 200. We're going to divide that by 1, 2, 3, 4, which is going to give us a mean. I don't need to write mean. I need to write x bar. I can do this. I believe in myself. X bar is equal to 50. Okay. Our next step is to take x minus x bar. So each of these points minus x bar. So that's going to be, each of these points is 40, 50, 50, 60. Okay? So x minus x bar, 40 minus 50 is going to give us negative 10. Okay? 0, 0, positive 10. Okay? Next, we need to square that. So that's going to be positive 100, 0, 0, positive 100. We need to add all these together. That's going to give us 200. Okay? And then we need to take that and divide it by n, which is 4 minus 1. Okay? So 200 divided by 3. 200 divided by 3 gives us 66.66666666. And then we need to take the square root of that, which is going to give us 8.16. So here is our answer. I finally did it right. It only took me, like 8,000 tries. It's fine. It's fine. Thank you, Felix. I needed that. I need some motivation. Here's number 15. From the following options, select the data set with the least variation. Okay. Dataset B has a standard deviation of 2.01 and a mean of 17. Dataset C has a standard deviation of 1.2 and a mean of 22. Dataset A has a standard deviation of 1.02 and a mean of 38. Dataset D has a standard deviation of 1.12 and a mean of 21. Well, guess what? It's going to be this one because it has the smallest standard deviation. Okay? Oh, wrong way. Sorry. Yeah, they didn't need, the mean had nothing to do with anything. The mean is just where it's sitting on the number line. Okay, it's the center point. The mean doesn't matter. They're trying to screw you up. Use the standard deviation, so this is the more complicated one, to compare the variability of the data sets round to the nearest hundredth. So we need to find the standard deviation for each one of these. We can do this. I can do this. I believe in myself. So let's find the mean first. For this one, which is x bar, is going to be equal to, let's grab my calculator. We have 4 plus 5 plus 7 plus 8 plus 11 is 35 divided by 1, 2, 3, 4, 5, 5. So our mean for this one is going to be 7. Okay, so the first thing we need to do is x minus x bar. So I don't even know if x bar is the correct term, but that's what I'm calling it. 4, 5, 7, 8, 11. There's a good chance that's not the correct term, but that's how I roll. So whatever, algebra. Okay, so 4 minus 7 is negative 3. 5 minus 7 is negative 2. 0, 1, 4. Okay. Now we're going to take these numbers and square them. So that's going to be 9, 4, 0, 1, 16. Now we need to add all of these together. So 9 plus 4 plus 1 plus 16 gives us 30. Okay. And then we're going to divide that by n minus 1, so 5 minus 1, which is going to give us 30 divided by 4. Gives us 7.5, and we want the square root of that, and that's going to give us 2.7, what? They're going to the hundredths. 2.74. Okay. Ta-chunk. Now let's figure it out for this one. X bar is going to be calculator time. Add them all together. 3 plus 6 plus 7 plus 9 plus 10 is 35 divided by 5 gives us 7. So boom, boom. Let's make our little graph. We have 3, 6, 7, 9, and 10. We're going to take our data point minus our mean. Chunk, 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 chunk. So 3 minus 7 is negative 4. 6 minus 7 is negative 1. 0, 2, 3. We need to square these to get rid of the negative numbers. 16, 1, 0, 4, 9. We need to add these together. 16 plus 1 plus 4 plus 9 gives us 30. So that's going to give us 30 over n, which is 5. That's how many numbers we have in our set, minus 1. So 30 divided by 4, which is also going to give us this same number because then we're going to do the square root. So it's also 2.74. So the standard deviation of data set A is 2.73. No. No, 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 no. The standard deviation of dataset A is 2.45. No, no, no. The standard deviation of A is 2.74. The standard deviation of B is 2.74. They have the same standard deviation, so both datasets have the same variability. Cha-chink! And this one's wrong. Okay. I'm so happy. I'm so happy. I don't know why they put you down there. 17. A 5-number summary gives the values 3, 6, 8, 12, and 18. Which two numbers in the summary are used to identify if there are any outliers? So in your notes, you should have the formula to find outliers. And outliers have to do with the upper and lower fence. And you need Q3 and Q1 to do that. So Q1 is right here, and Q3 is right here. So you also need the IQR to find these. So the upper and lower quartiles of 12 and 6 and the IQR of 6 are used to calculate that there are no outliers in this data set. I don't know what the IQR is. The IQR I haven't solved yet. It's Q3, which is 12, minus Q1, which is 6. So the IQR is also 6. So guess what? There's our answer right there. We'll check the others just to be sure. The maximum and minimum values have nothing to do with outliers. Well, I mean, not in finding out what the outliers are. The median of 6 and the IQR of 6, nope. The median alone, nope. It has to be that first one. Done living la vida loca. Okay, here's number 18. 3 video game players are arguing about whose scores are more consistent. Player A's scores have an IQR of 118. Player B's scores have an IQR of 208. Player C's scores have an IQR of 221. Whose scores are the most consistent? Okay, so IQR is the box on our box and whiskers plot. Okay, it's the middle 50% of their scores. So the person with the most consistent scores is going to be the person that has the smallest box. Okay, so it's not going to be C because they had 221. It's not going to be B because he had 208. It has to be A. And this is irrelevant because they're saying which is the most consistent, which means relatively comparing all 3 of these. It doesn't matter. They could all be completely terrible, but they're asking of the 3, who's the most consistent? It's player A because it has the smallest IQR. Okay. Tink. Yay. Oh, thanks, hon. Compare the graphs showing the number of siblings each student in Miss Samuel's and Miss Parker's classes has. Which statement is true? So we're comparing these. The data from Miss Parker's class is not symmetrically distributed. Yes, it is. Goodbye. The average number of siblings per class is the same for Miss Parker's and Miss Samuel's class. The average number of siblings. That's going to require some math. Let's keep going. There are more students in Miss Samuel's class than in Miss Parker's. Well, let's see. We've got 1 plus 7, which is 8, plus 3, which is 11, plus another 7 is 18, 19. So this is 19. This is 2, plus 5 is 7, plus 9 is 16, plus 5 is 21, plus 2 is 23. So no, they don't have the same number of students. Okay. There are more students in Miss Samuel's class than in Miss Parker's? No. On average, students in Miss Parker's class have more siblings. Okay, so now we need to find our... Oh, wait. I guess we don't have to worry because that's our only option left, but we will just to double check. We're going to see on average if Miss Parker's class have more siblings than Miss Samuel's. So let's find our... They're both symmetrical, so let's just find the median because it's going to be easiest, okay? Because median and mean are the same on symmetrical distributions. So we're going to start with the top one. We have 1. Oh, wait, these are all zeros. So now here's one sibling. We have 7, so 1 plus 1 7 times is 7. Then we have 2 siblings. We have 3 like that. So 7 plus 2 plus 2 plus 2. And then 3 siblings. We have 7 of them. So 3, 1, 2, 3, 4, 5, 6, 7, or you could have just added 21, and then 1, 4. Oh, it screwed it all up. I fat fingered it. So we have 7, and then 2 siblings. 2 times 3 is 6. 3 siblings, 3 times 7 is 21. And 4 siblings, just once. So that's 38 divided by 19, which gives us an average of 2. Okay, let's do this one down here. We have 0 siblings, 1 sibling, there's 5. So there's 5 plus 2 siblings at 9, there's 18. 3 siblings at 5, that's 15. And 4 siblings at 2, that's 8. So that's 46 divided by 23 gives us 2. So on average, students in Miss Parker's class have more siblings than the ones in Miss Samuel's class. I probably counted this wrong. 2 plus 5 is 7, plus 9 is 16, plus 5 is 21, 22. I didn't. Oh, wait. I crossed out one when I shouldn't have. It's this one that's the answer. Okay. Sorry. I don't know why I crossed that one out when I shouldn't have. This is the answer. They're the same. Okay. I got this. I got this. I got this. I got this. Yo. Okay. Compare the graphs showing the number of siblings. This is the same data as before. Which measure or measures of center are the same for both classes? Okay. They're both symmetrical. So both the mean and the median are the same. Both the median and the mode. Nope. Mode is how often a number appears. So the mode here is 1 and 3, and the mode here is 2. So that one's out. Only the mean and only the median. This is your correct answer. Okay. I'm so glad I didn't have to do these tests for the factoring. I hate factoring. Not show stand profits. The box plot shows the profits for a single taco stand before and after 8 p.m. Which of the following best describes... Ooh, hey. The box plot for profits after 8 p.m. So we're looking only at this blue one. Is it symmetrical? No. This is much shorter than this one. Is it skewed left? So this is most of the information right here. The head is going to be over here, and the tail is going to be like this. Okay. So actually, I lied. It's going to be the other way. This is the head, and then the tail goes over here. So it is skewed. The tail is what matters. So it's skewed right. There's no such thing as skewed center. Okay. Skewed right, because these are the outliers. All right. It's almost over, Felix. It's okay. The box plot shows the profits for a single taco stand before and after 8 p.m. What is the median profit for the standard operating before 8 p.m.? It tells us right here. It says median, and you follow it down. So guess what? It's 30. Hey, you did it. You did it. You did it. I'm proud of you. Tell me which ones I got wrong. I can guarantee I got something wrong. Bye.